Okay, hello geometry students, Dr. J here. Sad that we have to continue doing things this way, but under the current circumstances, we're going to make do the best we can. The good news is, I'm familiar with doing this, having done it in the past during the basketball tournament, so this isn't new for you either. The only difference is, instead of being in class and having a teacher hit play at YouTube, you're going to have to do this at home. I recognize your iPads don't have that capability right now to access YouTube to play. You're going to have to utilize a phone, desktop, or another laptop computer at home to watch this video, and then utilize your iPad then to do homework and interact with Schoology, etc., and Microsoft Teams. Okay? So, that being said, I want to get into a couple of things at the end of this week to get us set so that we can move in step with Mr. Stevens' class as well. We've got a couple of things I want to cover with you between today and tomorrow that I want you guys to become familiar with, and then we'll discuss them live on Monday or Tuesday of next week. Okay? So the first lesson is 10.4 in your book. It's page 554 is where we're starting. 554. Please notify me if you're having trouble accessing big ideas. I'll need to get the IT team to fix that, but in the interim I will make sure I take snips of each one of these pages of instruction as well as the homework and put it on Schoology so you have that accessible as needed. Okay? So again, it's page 554, 10.4, Inscribed Angles of a Circle. So, let me blow it up a little bit. Some vocabulary under core concept. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. Okay? So this angle B is the inscribed angle. The point of the angle is on the circle, and then the two sides go out to cross or touch the outside of the circle, making this an inscribed circle. The arc that forms between those two chords are called the intercepted arc. So you've got the inscribed angle, and then this blue line here is the intercepted arc created where those two chords hit the circle. A very strange word that you've probably never heard before, and if I'm being honest with you, if I heard it back in my geometry days in the 80s, I've totally forgotten it. Maybe it's a new concept, I don't know. It's the word subtend. Okay? If the endpoints of a chord or arc lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. I don't want you to stress too much about this term, I just want you to be familiar with it. So arc AC subtends angle B. I think it just kind of means that it's attached, it's in sync with angle B, the word subtend. And then chord or segment AC subtends angle B as well. Okay, so just keep that in mind. If you see that in the future, you know what subtend means. All right. Theorem 10.10. The measure of an inscribed angle theorem. The measure of an inscribed angle, here it's angle D, is 1/2 the measure of the intercepted arc, arc AB. Very straightforward. This angle measure is 1/2 what this arc measure is. Okay? So as the examples down here, example 1, find the indicated measure, the measure of angle T. So let's see what we've got here. We see angle R is 50. Okay? Based on that theorem we just realized, arc, the intercepted arc of QT, then is 100 degrees, because this is 1/2 of the arc. Here, this arc, RS, this subtended arc RS of angle T is 48. If this is 48, the angle is 1/2, 24. 1/2 of 48 is 24. Okay? So the measure of angle T we just calculated is 24 degrees. It's 1/2 the intercepted arc. Now it also asks us the measure of QR. Well, notice we've got a diameter here, right? Cuts the circle in half. You know that half a circle all the way around is 180 degrees. We know that this measures 100 because it's twice what the angle is. So I have 180 minus 100 equals 80 degrees. This arc measure is 80 because 100 here plus 80 gives you 180 all the way across. Not a big deal. All right. Theorem 10.11, inscribed angles of a circle theorem. If two inscribed, let me make sure I didn't miss any opportunity. No, I did not. All right, that's coming up. Oh, I'm sorry. I jumped. I didn't go all the way down. Find the measure of an intercepted arc. So with this example, it says find the measure of RS, okay, and the measure of STR, which is all the way around. I'm sorry, not arc, angle STR. Okay, so it says find the measure of arc, RS, and the measure of angle STR. Right there. Okay, so we want to measure this arc, the measure of this angle. Let me see if I can use a different highlighter to kind of point this out. So, we know that this arc SR is intercepted or subtends this angle. Right? Okay? This angle is given to us as 31 degrees. We just stated that the angle is 1/2 the measure of the arc, so that makes this arc 62 degrees. Twice 31. 2 times 31 is 62. Now, notice though, for the next one we're trying to find STR, it also hits that arc in the same spot. So arc RS subtends angle U and angle T. Since it's 62 degrees, this angle is 1/2 of that. It's also 31 degrees. Okay? Pretty straightforward. That leads us to this theorem. Inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay? Notice here, we've got this arc AB. Okay? Arc AB is intercepted right here by angle D. Right? Both lines come and touch the ends of each arc. The same is true of angle C. The two chords come here and intercept the angle in the same 2 points. Okay? And what that means is these two angles, and all kinds of fun with colors, are equal. Angle D and angle C are equal. That's all that means. Finding the measure of an angle. Given that measure angle E is 75. Angle E is 75, and it goes out and creates this arc. Arc GH. Well, notice angle F, which we're solving for, also hits those same lines. So what is the measure of angle F? Because it intercepts the arc in the exact same points, it's equal to angle E. It's also 75. It's not groundbreaking right there, okay? But something you need to know. All right. Monitoring progress. So what I'd like you to do, you have these 3 problems down below. Number 1, number 2, and number 3. What I'd like you to do is pause in just a second. Work through these 3 problems. Then when you've got them worked through, come back and I'll go over them. So go ahead and pause now. Okay, so coming back, problem number 1. Find the measure of the red arc or angle. Okay, so this is an angle. We have this angle. It wants us to find the measure of angle G. Okay, angle G. Well, angle G intercepts arc FH. and we're told that arc FH is 90. So you know by now that this angle then is 1/2 of this arc. So angle G equals 45 degrees. Easy peasy, a lemon squeezy. All right, number 2. The reddened area is now the arc. What's the measure of this arc? It is an intercepted arc of angle U. Angle U is 38 degrees, so the arc is just opposite of what we did here. The arc is twice that. 2 times 38 is 76 degrees. Okay, and lastly, number 3, we want to solve for angle X. Notice the reddened area here. Angle X is what we're solving for, question mark. Notice that angle X intercepts arc WZ. Well, angle Y also intercepts arc WZ. So that means these two angles are equal. Angle Y is 72 degrees, so angle X is also 72 degrees. Very simple. Again, with this and with anything we do moving forward, we're not in line, because you could be doing this already the whole school year. When you have these blue buttons on big ideas, you can click on them and a little video will pop up to show you what I just showed you. Maybe you'll like the way they show it better than I did. That's fine, as long as you get the concept. All right, let me see where we're moving to next on the hit parade. Inscribed polygons. This is page 556. Inscribed polygons. A polygon is an inscribed polygon when all of its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. Not a circumcised circle, please. A circumscribed circle. Okay? An inscribed polygon is when all the corners, the vertices, touch the edge of the circle. That's an inscribed polygon. What kind of polygon is this? That's right, it's a pentagon. All right? And then a circumscribed circle is the circle that goes around the polygon. A couple of theorems to note. Theorem 10.12, the inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter, then the triangle is a right triangle. And the angle opposite the diameter is the right angle. All right, so if you've got this triangle inscribed in a circle, and the one side is the diameter, by definition of this theorem, this is a right triangle. And the diameter is the hypotenuse. Where is the right angle of a right triangle? It is opposite the hypotenuse. So angle B is your right angle. Okay? So that's what that means. An inscribed quadrilateral theorem, 10.13. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Please be reminded, what does the word supplementary mean? It means they add up to 180 degrees. So, angle F plus angle D equals 180. Angle E, angle G equals 180. Okay, the opposite angles are supplementary if a quadrilateral is inscribed inside of a circle. Any quadrilateral. Okay, so here's the examples. Find the value of each variable. So in letter A, we have a triangle inscribed inside of a circle, and one side goes through the diameter. So by definition, this makes it a right triangle. If one side goes through the diameter, it's a right triangle, and that diameter is the hypotenuse. The angle opposite the hypotenuse is the right angle, which equals 90 degrees. So this says 2x. So we say 2x equals 90, but obviously x equals 45. We need to divide by 2. Okay? Over here, we have this quadrilateral inscribed into there with letters z and letter y. We just described a theorem where the opposite angles are supplementary. So we have z plus 120, sorry, try that again, z plus 80 equals 180. Subtracting 80 from both sides, z equals 100. And y plus 120 equals 180. Subtract 120 from both sides, y equals 60. Okay, pretty straightforward stuff. I'm skipping that, because we've got stuff we've got to get through. So I want you now to get ready to pause. On this section, we're doing numbers 4, 5, and 6. We're not doing number 7. We're doing 4, 5, and 6. Okay? Pause now, and then we'll come back and talk about it. Okay, so number 4. Find the value of each variable. We see here we've got a triangle inscribed inside of a circle. One side is the diameter, so that makes it the hypotenuse. The angle opposite the hypotenuse is the right angle, so quite clearly x equals 90. So we just got to solve for y. Please remember what I've told you. The one thing, the most important thing to remember about triangles, the most basic thing to remember, all the angles add up to, you got it, good job, 180 degrees. So I know this is 90 and this is 40. 90 plus 40 is 130. I take 180 minus 130 and I get 50. Y equals 50 degrees. Okay? Number 5, I have this quadrilateral inscribed in here. Solve for x and for y. I know that opposite angles are supplementary. They add up to 180. So I have y plus 68 equals 180. Subtract 68. Y equals 112. Or I have x plus 82 equals 180. Subtract 82. X equals 98. X is 98, y is 112. And over here, I've got 2 different variables, but that's fine. I know that, first of all, 8x plus 10x equals 180. 18x equals 180. Divide by 18. X equals 10. Okay. The other one is, 2c minus 6 plus c equals 180. 3c minus 6 equals 180. 3c equals 186. C equals 32. All right, x equals 10 and c equals 32. If you're confused on any of these, please hit these triangular buttons. You can watch it again. That covers the lesson I wanted to go over with you. It's nothing terribly hard. It's a good way for us to get started in this unusual circumstance. So your homework is going to be 558, page 558, 3 through 15 odds, and then 19 and 21. Okay? 3 through 15 odds, then 19 and 21. Not too terrible. I'll have snips of homework and instructions in Schoology, as well as an assignment assigned to you in Big Ideas and in Schoology as well. Please submit in either form. Honor students, of course, you have to submit only in Schoology at this point, and that's fine. Off we go. I'll speak to you all again in person live on either Monday or Tuesday of next week.